Hello grade 11s, welcome to my channel, and today we're going to attempt to do a full paper for your rest of the year, because this is the paper that is at the level of your finals. Alright, so I figured let's just do a full paper and establish certain important areas that you should be looking at as you work through the remainder of the year. Now we're going to start with this maths paper 2. I'm not sure where it came from, but there's this what you call Billy Naya cluster. I'm not sure where that is. Anyway, you know where that is. Let's just move. So we've got instructions which you don't want to operate without. So essentially, instruction 4 is important. Show all calculations, diagrams, graphs, etc. Which you used in determining your answers, and technically the rounding off part. This says to 2 decimal places. Okay, so that is very important, and the rest is pretty straightforward. Let's just keep working. So let's start with question 1. So we're dealing with statistics, which is what you will be asked in grade 12. Same way as you will be asked here. And then there will be what we call the least squares regression line in grade 12. So let's see. Now we're told here, Dylan plays for his cricket team. The number of runs scored by Dylan, so we're talking about the runs scored by Dylan in 8 games. How many games did we have here? 8. That he betted in is shown below. Okay, Dylan was given out in all the games. So this is 1, 2, 3, 4, 5, 6, 7, 8. Those are the games he took part in. Okay, so these are the games Dylan participated in, and those are his runs that he scored. Anyway, so determine the mean average runs scored by Dylan. Okay, so basically the mean. You can either say the average of the runs, or you can just say the mean. Anyway, when we do that, we just put it in the calculator. We'll just go to answer 1.1. So we've got 1.1.1. So here we just simply go into our calculator, we hit mode, and then we press option 3, which is statistics, and then we go for one variable, which is one var, which is option 1, and then we just insert the data by pressing the number 21 and press equal sign. It gets inserted. 8 equal sign inserted. 19 equal sign inserted. 7 equal sign inserted. 15 equal sign inserted. 32 equal sign inserted. 14 equal sign inserted. 12 equal sign inserted, and you can see there's 8 data points there. Press an AC button, we go to shift and press button 1, and then we go for option 4, which is VAR, and we're looking for that X bar. Once you see that X bar, that's our mean. And then we press that option 2 and equal sign. It gives us 16 runs. Okay, not a problem. So we get a mark, or we get 2 marks there. So this is mostly calculator work, guys. So 1.1.2. It says now determine the standard deviation. Again, we just hit that AC button, shift, option 1, then option 4, and then the standard deviation. You will see this small letter sigma in the Greek letter in terms of our x, which is the data. So we press option 3, and then it tells us that we've got 7.55. Okay, that is the standard deviation right there. Not a problem. So we get our 2 marks. Again, easy stuff. And then we move on to 1.2. 1.2 says a certain school has 60 learners. wrote mathematics examination. The maximum mark was out of 100. Okay, now use the information below to draw a box and whisker. So again, this is very important to know how to do. Diagram for the mathematics results in the diagram sheet 1. So we're also directed what to use. Okay, great. And then the minimum mark is 30. So we know that, okay, these kids in this particular school and these 60 learners, the lowest mark was 30. Okay, and then the range is 15. So what is the range? The range is basically the difference between the maximum and the minimum value. So that's what we call the range. So now we are saying the range is basically 55 equals, now what is the maximum value? We don't know. Don't use that. That is just the total. And then the minimum value here was 30. So we can say therefore our maximum value is going to be 55 plus 30, which is 85. Okay, so we need this dude. We do. Okay, so that was 85. That is important. And then also be aware of this formula. It will take you to heaven. Okay, so that is the determination of our range. I'm just messing around now. I don't know why I'm doing it. Anyway, so let's not waste time. Then we're told here the upper quartile. The upper quartile is basically Q3. Okay, Q3 is 70. So we are sorted. We can see that our Q3 is 70. All right, okay, all right. So that's not a problem. And then we are told here the interquartile range. What is the interquartile range? The interquartile range is 30. So what is the interquartile range? The interquartile range is basically Q3. So IQR is Q3 minus Q1. And we can see here we didn't have the lower quartile. That's what we want. Okay, so this one tells us that we have 30 is equal to Q3, we were told is 70, and then Q1 is what we want. So this implies that Q1 is basically 70 minus 30, right, which is going to be equal to 40. Not a problem. So that is important because we need that value. And then we are told here the median is 55. So that's fine. So the median is halfway. So we can actually take this grid now and start working. So where is that? Where is the grid? We are told to do some things. So we've got fancy stuff that does fancy things. So let's do it. Let's do it. So take and put. So look. So I don't know, guys, do you really have to show those calculations now? They just said draw. So I believe you don't need to worry about too much at this point. Of course, we'll write your name there. okay? And then so that when this goes missing, they can determine who it belonged to. So when we draw a box and whisker, we always look at, well, why am I on Euclidean geometry? So we always first have to look at our Q1, Q3, and Q2, okay? So this one is basically Q2, okay, the median. So we know here we've got a point on 55 here, and then we've got a point on Q1 is 40, and then we've got a point on Q3 which is 17. So basically here we're doing this. I knew it was gonna do things. Okay, let's try again. So we've got 40 to 70. So we just make our box there. And then we saw that our median was 55. So there it is. Okay. And then we are going to do things like this. The minimum we were told is 30, so it goes here. Sobanje wena. Kubaning olibiana biano. Okay guys, it may be skewed a bit, doesn't matter. So there's our whisker there at 30. And then the other one goes to 85 because we saw that our maximum mark obtained by this kids, but this kids ziyadlala lezi asafiki akho 100% nyani we want. Okay, it may not be straight, of course we're going to use a ruler. I don't have that now. So basically, that is the story that you are supposed to project, because a box and whisker will have a minimum, right? This is the minimum mark obtained. This is the maximum mark obtained. So no one got 100% here. And then this is half. This is what was obtained by half of the school kids. So that is basically halfway. Yeah, so you can even label if you want Q1, Q2, Q3, but don't put these labels in there. The box and whisker must be clean. All right, so that is fine. We are done. So what do you do? What did we have to determine here? You really had to determine the minimum value because the Q1, because we didn't have, it was not given, and we had to determine the maximum value. And what else did we have to use here? We got Q1, we've got the maximum value, yeah, that's it. And then we can say here, how many marks were we getting? 4 marks. Okay, we can get a mark for that, knowing where to position it. And essentially I don't know, for any one of these two that were given, either the minimum or the Q3, we can get a mark, or perhaps we say half a mark for that, half a mark for that. I don't know. You will look in the memo for a formal marking guideline. Okay, so let's do, this was 2, this was 1.2.1. okay, so let's do 1.2.2. What is the story? It says how many learners scored less than 70%. Okay, in terms of percentiles, okay, you should know that this is 25%. So Q1 is 25% of our data, this is 50% of our data, and Q3 is 75% of our data. Okay, so essentially, technically, so we're saying scored less than 70%. So 70% was scored, 70% was scored by 75% of the class. So that is exactly the people, they all went up to 70, so it's going to be like that. So basically we're going to say this is 70. Oh, so this is 75%. Remember, 75% got 70. So the mark here is 70% in terms of the mark, or 70 over 100. But that was scored by 75% of the class. So that is what we want. So this is 75% is over 100. Then we multiply by the number of students who scored here. But now, how many students did we have? We had 60 learners. So we're going to multiply that by 60. So we sort it out. So this is 75 divided by 100 times 60. So it was 45 learners. Okay. Maybe let's write a bit properly. So this is 45 learners. Okay. Not just 45 Magandas, okay? Hi, anyway, anyhow, so let's go on. That's it. We've done with 1.2, so we go for 1.3. And then 1.3 says, as part of an environmental awareness initiative, learners of Bafflesdale Secondary School were requested to collect newspapers for recycling. The cumulative frequency graph, okay, we call it a cumulative frequency graph, or this is called ogive, not any other way, okay? Don't call it ogive or ogive. Anyway, it's fine, guys. You are always told there's no master of pronunciation, but the reality is there is technicalities to that. So it's called an ogive, not anything else, but it doesn't matter what you call it. Below shows the total weight of the newspapers in kilograms. So we've got our unit of measurement in kilograms collected over a period of 6 months. Okay, by 30 learners. There's too many things here. So we've got 30 learners doing the things. Okay, there's our cumulative frequency graph. And you know that we always plot the upper limit of every class. So how do you do a cumulative frequency graph? You always plot the upper limit of every class. Okay, you plot the upper limit of every class with the cumulative frequency value. Okay, so that is the story, so please note that. So all we can see here is that this is anchoring at 20. Okay, maybe let's use another color. So this is anchoring at 20. Now, if it is anchoring at 20, it means 20 is the upper limit of the lower class, okay? And then 30 is the first class, okay? And that is the upper limit of the first class. And that becomes the upper limit of the second class. So if we're to do this, this is now the first class right here. And this is the second class right there. And so on. That's how it goes. Okay, please be able to read any graph that you are given, especially when it is part of your syllabus. Now let's see, determine the model. So they probably wanted to say modal. The modal class is the class that becomes the steepest in terms of gradient. And if you look at these gradients, you will see that this gradient is, these ones are slow, but the critical point is at this gradient here. That one is steep for sure, but what about that one? That one looks a lot steeper than that one. Okay, there's almost like a bend in there. So you can see that the steepest is basically this region right here. The steepest is in this region. So it is this class basically. It is this class right here. Okay, all right, okay. So we can see our upper limit of that class is 60 and the lower limit is 50. All right, so to write this out, we're going to say now the weight, because we're talking about the weight in kilograms, is going to be less than or equal to 60. And then this must be greater than 50, because 50 is the upper limit of a lower class. So we can't use that with an equal sign. But I mean, sometimes it doesn't really matter, but yeah. The logic says the equal sign should be with the top one, because that's what we're plotting. This one is a means to an end because it gets plotted for the previous class. Okay, we're getting our 1 mark, nice and easy. So here you just look for the steepest gradient. Because the steepest gradient will tell us that the most of the students were there. Okay, we're in that bracket. Okay, the next question says determine the median weight. So the median weight here, we just have to find halfway of our cumulative frequency graph. Once we find halfway, remember we've got here the top most part goes to, let's see, where does this line go? What is that plot? So that plot goes with theta, right? Don't do hearts when I'm on. I am not romantic, okay? Please, man. So it goes with theta, right? Right. And then now halfway should be 15. We just simply go to the graph from there. Okay, so sometimes you can make it broken. Sometimes you can make it whatever. So as we go to the graph, it lands us at there. So now when we take it down to read off our weight, of course this one needs to be vertical, so use a ruler. You use a ruler. So if we read there, we can see this is 50 and then halfway should be 55. And then we've got 60 there. So essentially this says we are almost like 53 there, because it's almost like halfway between 55 and 50. So we can simply say this is approximately 53. Okay, or perhaps 50, yeah, 53 roughly there. So this is 1.3.1-ish. And then see again, go 1.3.2. So this is approximately 53 kilograms. Easy stuff. So you know the procedure. So you always take half of the data points on the cumulative frequency. Then you go to the polygon, the ogive. Then you read it off on the x-axis. Now it says how many learners collected more than 60 kilograms of newspaper. Now we want the number of learners. Okay, so we can see that, well, technically this is asking us about, so this is asking us about this region of our graph. Okay, so this didn't come out right, man. Yeah, when man. Yeah. So this is asking about this region of our graph, okay? Because more than 60 is this region here. So we can tell here that more than 60 was from 60 to 90, okay? So this is this region. We're talking about this region. 60 is not included because we're saying more than 60, so we're going here. So that's what we're talking about. So what are we doing here? We'll have to look at what was the plot of the 60 going to, because we need the difference there. So that plot right there, if this is 20, let's say 1, 2, 3, 4, 5 years. So this is 23. Okay, so we want to know what is that. Okay, so that is 23 against the top, which is 30. So basically, for us to know how many students got that, we just need to know the number of students. That was the difference between those two little points. So this is 1.3.3. So this is basically going to be 30 minus 23, which is going to be equal to how many? 30 minus 23 is 7, right? Yeah. Yeah, bro. So we've got 7 learners. Okay? Because the question was all about the number of learners. So that is the story. So that's what we are doing. So pay attention to what we did here. We took that highest cumulative frequency and subtracted that one at 60. That gives us the number of learners that actually were in that bracket. Okay, so we get our 2 marks and we move on. So we get our 15 marks, nice and easy. So these are the things you want to look up to or to look out for. Okay, let's do question 2, which is analytical geometry. All right, sorry for that. Now question 3 starts, of course, use the doctor approach. Okay, I would call it a doctor approach. In fact, do that for maths as a whole. What is the doctor approach here? In the doctor, you always come in first and then you tell your story, right? Or you say what is bothering you, right? Right. And of course, the doctor is listening to your story. As he's listening, he's doing something called an inspection. He's inspecting you. Okay? And while he inspects you, then he will follow by examining you. Okay? And then after that examination, he makes a diagnosis, at least a provisional one. Sometimes he may need tests to confirm or to disprove, and then do the final treatment. Okay, so that's how medicine is practiced. You understand? So always when you're given information, take that information in detail as it is given. Give an inspection. Does it tie up with some of the things you see? then you'll have to perform an examination. An examination could easily be a calculation or whatever determination you may need to do. Of course, the answers are the diagnosis, right? Yes. And sometimes to test, this is what you call checking your answers. Because sometimes you get an answer, but you're not sure if it is correct. Then you may have to check it. That's what you would call doing some tests. Now you're testing it back. And then once you're sure, this is a confirmation of whether you have a correct answer. So that is what I would call a doctor's approach to answering math questions. In fact, both maths and physics, what am I doing? This is the doctor's approach. So I don't know, guys. I always come up with some lousy terms along the way, but yeah, that's it. So the doctor's approach, please, 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 it is noteworthy. If you don't employ it, you will embarrass yourself, believe me. Anyway, how long was our paper, by the way? 2 hours. So yeah, we got to move. We're wasting it. Okay. So now in the diagram, A, so there's coordinates. See, we are given and we are inspecting it. So that is A, coordinates is 9 and minus 1. So there it is. It's on the right position. Okay, so, and then we've got B, which is coordinates 3 and 11. Again, it's in the right position for those type of coordinates. Then we've got C. Maybe let's change a color for B. And then for C, this guy is not given, so it's a hypothetical point, so we will have to determine those coordinates somewhere, somehow. Our vertices of triangle ABC. So where is that triangle? This is our triangle ABC. Please make a habit of identifying your workspace. That's an inspection, guys. It's very important. So if you're not methodical, you will fail in medical school, okay? So don't go there if you're already erratic. So we can see here we're given this line. So now we're overly inspecting, but nobody mentioned anything. But sometimes you don't need a second invitation. So we're told that that line is parallel. Okay, so let's keep going. But we can already see here there's extras again. We see that that point or that side is equal to that side, meaning this line MN is the midpoint of AB, okay? And if this side is parallel to the third side of that triangle and it cuts the midpoint, it in effect tells us that this is also the midpoint of that side, okay? So that is just stuff from the midpoint theorem. Okay, you can call it a converse of the midpoint theorem. All right, great stuff. So you always identify some of the laws that may govern issues in your given pieces of information. And then now we're told M is the midpoint of AB, so already could see that. N is with those coordinates, so not a problem. We can see our N has the correct coordinates because that position makes sense for those coordinates, okay? Is a point on CA such that MN is parallel to BC, so we can see that. BC produced, now when you produce a line, it becomes the same straight line, or it at least carries the same gradient. Maybe not quite a good extension right there. Okay, so that means we have the same line. And what does that mean? It simply means point E, C, and B are collinear, okay? So that means they are on the same straight line. So this simply says these are collinear points, and we can already appreciate the coordinates of our E. They're in the right position as well, or at least a sensible position. Now what can we do with this piece of information? Well, what we can do is that we've got two coordinates on EB. That means we can find the gradient of EB and use either one of those points to work out the equation of that line. 2, since we can see there's an angle of inclination theta there, we can use that gradient of EB to work out that angle of inclination. So those are the things we can do. The second is that seeing that this line EB is parallel to NM, this simply says they have equal gradients. So we can use point N to work out the equation of NM. Number 1. Number 2, since N is the midpoint, of course, by following the converse of a midpoint theorem, we will see that essentially we've got coordinates of A and N. We are missing C, and since that N is the midpoint of CA or AC, we can actually use that expression to work out those coordinates. Secondly, we can also work out the coordinates of M because we've got the coordinates of the edge or the edges of that line. Okay, so we can even do the gradient of that line AB. We can even do the equation of that line AB. So we can pretty much do a lot. And then if we're looking again, we've got beta there. So beta technically is the angle that the y-axis make with the line AC. So this is easy because we know that at the origin we've got 90 degrees. Okay, so if we've got 90 degrees, we've got a right angled triangle there. Knowing that we can get theta and we have 90, we can work out that from just 3 angles of a triangle. Okay, so we can pretty much work out everything. And then of course, once you are done doing this, just do a run through, read this question so that you can determine what techniques must you use to answer what question, so that you fall into a nice pattern, so that you don't have to determine too much. Everything just follows one another. But we're not going to do that today because we know that, you know what, let's just keep it simple today. But as we go along, I will show you how this is so useful. So question 2.1 says determine the coordinates of M. Now you know that when the question says determine, you've got 2 techniques, inspection and calculations for your grade 12. So you can decide which one is going to work. Well, it's obviously going to need this technique, calculation. So we can see that M is basically going to be x at A plus x at B over 2 is to y at A plus y at B over 2, because M is the midpoint. So we go on, and then x at A is 9 plus 3 over 2 is 2. This one is minus 1 plus 11 over 2. Okay, so therefore our M is given by this 12 divided by 2 is 6 is 2. No, why is it so far apart? Now this is 10 divided by 2, which is a 5. Okay, does that make sense? You have to inspect it, that is testing it. And look, if F is at 8 and M is just below that, it makes sense, right? And if we've got 9 there and then M is before that, that should make sense for a 6, even though we may not be exactly correct if we made mistakes, but we know that technically our answers make sense, so we can accept these 2. So you get 2 marks in the answers, but we need to see how you got up. Maybe we can do this and say fine for those substitutions, and then for the final answer, that's how you get the 2 marks. So let's do it. 2.2. Now we've got determine. Again, you've got a question that says determine the gradient of Mn. Okay, now Mn is a bit of a special one, because when we look at it, we know that it's going to be by calculation. Okay, so we see that that line is parallel to EB. So we know that, fine, we can just simply say MN. Okay, the gradient of MN is going to be equal to the gradient of BE. Okay, why is that? Always remember, this is geometry. In fact, this is maths. We need to find every possible reason. We know that it is given that EB or BE is parallel to MN. Okay, so parallel lines have equal gradients. But now we want to use this as a means to an end. That means y at B minus y at E over x at B minus x at E is that gradient, and therefore y at B is 11 minus into 0. It's just not an important thing. Then x at B is 3 minus into minus 8. Okay, so this is 11 over 11, which is basically going to give us 1. Okay, so that's it. We expected a positive gradient because now we are testing it by checking it out. It is a positive slope, so that gives us a positive gradient. So that answer should make sense, right? So essentially, what is important is that statement, then the substitution and the answer. Okay, the statement with the reason. Remember, if it doesn't have a reason, we are confused what you're talking about. Remember that. 2.3. Okay, so 2.3 says hence or otherwise the equation of Mn. So we saw that we could do that pretty easily in the form. Okay, that means just the linear form, the standard form. 2 marks. So that is easy because now we know that Mn is such that y is equal to x because the gradient is 1 plus c. Okay, so now through n, which is a 2 is to 1, we substitute stuff like this. So it's going to be 1 equals 2 plus c. So therefore our c is going to be minus 1. We can therefore say y is equal to x minus 1. That's it. So that was pretty easy. So what was most important here was this substitution into that equation, and then that answer is marked as part of the final answer. Okay, keep going. 2.4, then it's divided into a. Now I told you, give a reason why n is the midpoint of AC. Like I said, you could see that if this line is parallel to the third side and is cutting one side in half, it will also do the same to the other half. Okay, so that's the midpoint theorem. So we can just say converse of the midpoint theorem if we want. Because you can say it's a mini converse. I don't know how you're going to phrase that, but that is the most important thing. So we can just say it's the converse of my midpoint theorem of triangles. Okay, because like we said in the midpoint theorem, we're saying if a line cuts the opposite sides of a triangle in equal halves, that line is going to be parallel to the third side and half of the value of that third side. But now we are also given the fact that this is cutting the midpoint. Sorry, it's cutting the other side in half. and it is also parallel to the third side, therefore it should cut the other side in half. So I think that is the best way you can go about it. So you get your 1 mark. So we look at B. B says, hence find the coordinates of C. Easy. Now we can say C again is basically the x coordinate at C plus the x coordinate at A over 2 must be equal to the x coordinate at N, the midpoint. And then we're going to say y at C plus y at A over 2 should give us the y value at N, its midpoint. So this implies now that C is going to be in this manner: x at C plus x at A, this is plus 9 over 2, is going to be equal to 2. This one is going to be y at C minus 1 divided by 2 must give us 1. Say therefore our C is going to be now you do some gymnastics. You cross multiply the 2, it's a 4. You cross multiply the 9, so it's going to be minus 9 plus 4, that is minus 5. Make sense? Yes, because this is before 8, so that coordinate makes sense. So when we test it, it's correct. And then we cross multiply the 1 data 2, we transpose the 1, it becomes a 3. Does it make sense? Yeah, it should to some extent. So let's leave it without saying too much. So what are we getting here? We were getting 3 marks. Okay, so I believe this is important. And then those 2 coordinates are important because they're a bit special. You know, they deserve some of the attention that they can get alone. Okay, 2.5 says if A, B, C, D in that order. So we're going to get A, B, C, D is a parallelogram. Okay. So if that is the case, it means D is a point somewhere. Okay, let's try to do it. So A, B, C, D. So we always follow the order that we are given. So essentially, that would be something like that, right? Most likely. Of course, not exactly 100%. At this point, you just want a sketch, okay? Maybe it's too long. All right, so that is what we are told we've got. Okay, doesn't matter that it's doing crazy things. So our D should be a point there. X is to Y. Okay. All right. Okay. So what do we know? We know that N is the midpoint of CA. So we know that the diagonals of a palm bisect each other. So there is another diagonal here. The other diagonal should be coming from there, passing through the point of intersection and getting there. Not quite. Whatever, man. It looks like it's going to run me into some kind of anger issues here. Whatever. Okay, guys. So you get the idea. Sometimes it gets a bit messed up. So it gets a bit technical. So all we're trying to understand is that the diagonals of a palm bisect each other at a common point. And we already know that point. We already know the coordinates of B. So we are saying we can actually work out the coordinates of D using the midpoint situation. It says determine the coordinates of B. Do you see? So we're going to do it. So we're going to say, fine. We know for a fact that A Now, we need to start by saying BD is equal to, sorry, no, let's not say that. We're going to say N is the midpoint of BD. Okay, what is that? The diagonals of a parallelogram bisect each other. Okay, so this statement is important, very important. It's a mark. Okay, you can see there you're getting 4 marks, so there's no child's play there. And then this implies what? This implies now that D is such that x at D plus x at B over 2 must give us x at N, its midpoint. Likewise, y at D plus y at B over 2 should give us our y at N. Which implies also that D is going to be x at D plus 3 over 2 is going to be equal to 2. And then y at D plus 11 over 2 is going to give us a 1. So now we can make our conclusion that D is, we cross multiply that 2, it's a 4. We subtracted 3, it's a 1. Makes a bit of sense, right? Yes. And then you cross multiply the 2, it's going to be 2 minus 11, that's going to be minus 9. That looks a bit sensible because that position of that D is making a bit of sense. Okay, great. So what do we do now? Of course, we're getting 4 marks. So I know for a fact that those 2 are going to carry the marks and then the substitutions. And that's how we're getting those 4 marks. Easy stuff, okay? Easy stuff. And then let's do 2.6. Now it says determine the size of beta. All right, so beta, we saw that, we saw that we need this triangle there, okay? Whatever that triangle is, so it's going to be FEO, okay? So we can use 3 angles of a triangle, but first of all, we're going to need our theta there. Once we work out that theta, it's simple. So let's see. We can say the in triangle EFO, okay? Always state the region that you're working at. What do we see there? We know that tan theta, because we need that angle, is equal to the gradient of BE. Okay, great stuff. That is the angle of inclination. You don't need to explain that. So this implies that theta, or this implies that tan theta, let's substitute. We got the gradient to be 1. So this is equal to 1. Okay, great. And therefore, theta is going to be the shift tan of 1, which is 45 degrees, right? Let's just double check. Yeah, there's no doubt about it. So theta is 45 degrees. Okay, so what do we do then? We're going to say then we can see that beta plus theta plus FO, okay, we can just say EOF equals 180 degrees. What is the reason there? This is the sum of 3 angles of a triangle. Okay, so we've already stated what triangle we're talking about. Okay, so this implies that beta plus 45 degrees plus EOF is the origin, so you don't need to explain that, equals 180 degrees. Okay, and then this also implies that our beta is going to be 180 degrees minus 90 degrees minus 45 degrees. Okay, maybe let's even say therefore here. So let's work it out. So it's going to be 45 degrees actually, because those are complementary angles. All right. Okay, all right. So now we are sorting things up. We're sorting things up. So again, we're getting 4 marks. So you could see that you could not just take it too easy. So what is important is working out this angle. This statement and its reason is important. This substitution into a particular formula is important, and that answer. The rest is history. Okay, the rest is history. Anyway, so let's do the last question now, before we get to the hour. So now it says here, calculate the area of FOE. That's pretty easy, because we know for a fact, without a shadow of a doubt, that this side is basically the horizontal distance from the origin to E. So that is 8 units. Okay? And then we also know that this side is basically the vertical distance from the origin to F. So that's going to be 8 units. Okay? So it's a right angled triangle, so easy stuff. So we can just say area of triangle FOE is going to be equal to half. We can choose the base to be OE times the vertical height, which is OF. Easy stuff. Or maybe let's start. Remember, formulae are important before you substitute. So it's half base times height, which is half of OE times OF. So this is going to be a half. OE is 8 units. OF is also 8 units. So basically this is half of 64, which is 32 square units. Okay, so that's it, guys. Nice and easy. Nice and easy. So basically the substitution, okay, here perhaps this substitution and knowing those values and the answer is important. So we take our 22 marks with a big smile. So guys, don't fail grade 11, please, man. Grade 11 is the, okay, let's not say things that we might regret saying. So that's it. Let me just breathe for a moment. I just need to drink some. Okay, let's do trigonometry, which is question 3. Now, question 3, very straightforward. From grade 10 already, you've been doing this. So 3.1 says, if sine of 23 degrees equals P, without using a calculator. So basically, we don't want to see decimals and we don't want to see just answers. Okay, express the following in terms of P. Now let's go for it quickly. 3.1, we are told sine of 23 degrees equals P. Always express it as a fraction. Okay, it's very important. So this implies that we have our terminal arm diagram on the Cartesian plane. 23 is an acute angle, so it's an angle in the first quadrant, so we know that we can easily do that. Okay, so that should be 90 degrees. Okay, so that is 23 degrees. So you are taught in school that if you ever work out any angle, work out the rest if you have a triangle. So this is basically 90 minus 23. This should be 67 degrees. Okay. So, sorry. Calculate all possible angles once you get to this. And then what is sine is opposite of adjacent. Sorry, of a hypotenuse. So this is P. And that's the hypotenuse. And then we know that x squared plus y squared equals r squared. X is what we want, plus 1, no, P equals 1 squared. Therefore, we've got x squared plus p squared equals 1. Therefore, x is going to be the square root 1 minus p squared. Okay, sometimes it's important for you guys to show the step, but in grade 12 you don't need to show it. You can just show up with that 1 minus p squared. We know how you got it, but in grade 11 please show it. It's important. That calculation is a mark on its own. Okay, so let's kick it. So 3.1.1 says let's find 10 of 23 degrees. 10 is opposite of adjacent, so it's going to be P over the square root of 1 minus p squared. So we're getting 3 marks. Obviously, these 3 marks, the way we're getting it here, this is 2 marks on its own. Okay, but determining the value of p of the adjacent, that's how you get that extra mark. Okay, so let's do 3.1.2 says sine of 113. Now once you get an angle greater than 90, you always have to think of how do we do this. What is 113 in relation to 23? Let us see. 180 minus 113 is 67. So there's 2 ways we can do this. We can see 67 is on our diagram. So we can simply say this is basically, you can look at it in 2 ways. This could be sine of 90 degrees plus 23 degrees. Let's just choose that one because the other one we really did not have, but you must think about it as well. Yeah, so that one is simpler. And then now we know we're going to reduce this using cofunctions. The cofunction of sine is cos, but sine in the second quadrant is positive, so our cos is going to be cos 23 degrees, which is going to be adjacent, which is the square root of 1 minus p squared over 1, which is just simply the square root of 1 minus p squared. So that's how we do that. You will always require to use some reduction formulae, and you will always need to use some, in grade 11 you have the square identity, so you will need the tan identity, the square identity, and the reduction formulae, and of course just trig ratios. Okay, how would you have done this one otherwise? You could have said sine 113 degrees is basically equal to sine of 180 degrees minus 67 degrees. Okay, now sine, when you reduce here, is going to be sine of 67 degrees, right? Now in that diagram, the opposite side is the square root of 1 minus p squared over 1. So it's still the same thing. Do you see? You're not losing anything by an approach. As long as it gives you the answer, it is cool. Always use that diagram that we have, or attempt to combine some special angle and some of the big anchor angles like 0, 90, 270, 180, 360. Not a problem. So let's move, guys, before we lose time. Now 3.2, maybe let's just go on a new page, should we? Okay, maybe let's try. So 3.2 says simplify without the use of a calculator. So that means we're going to need some tricks. 10 minus 315 degrees minus cos 780 degrees. So here we need to employ reduction formulae, right? So tan of a negative angle basically is minus tan of that negative angle, but now looked at positively, minus cos of 780 degrees. Okay, now we need to employ reduction formula. This is in the fourth quadrant, so let's say 360 minus 315 is 360 minus 45, so this is 360 degrees minus 45 degrees. So we always show that cos 780 780 is a bit nasty, right? Yeah, man, this is 780 minus 360. So this gives us 420. Okay, so this is fine. We can say this is the same as 360 degrees plus 420 degrees. Okay, this is going to be a bit of a step. So this is the same. I mean, 10 is negative in the third quadrant, so this is minus into 10 45 degrees. Okay, sorry, minus 10, because 10 is negative in the fourth quadrant. So this is minus, because remember when you're saying 360 plus, this plus just says in principle we're in the first quadrant. It doesn't matter how big that angle is. So this is going to be the same as cos of 420 degrees. We're reducing. And then we sort things out. This is going to be tan 45 degrees minus cos, and then we need to reduce this further. So let's see what happens. So this is the same as 360 degrees plus 60 degrees. Let me check. Sometimes it's easy to convince yourself of a wrong thing. Yeah, it's true. And then again, minus. Now, cos of 360 plus, again, we're in the first quadrant. So this, see, the theory or principle is correct. So this is the same as cos of 60 degrees. Now we've got special angles. we know that 1045 is 1. Okay. So we're going to just write here. This is 1 minus, cos of 60 is a half. Great. So we got minus a half. No, you're lying. We just have half. Okay. So that is it. Now, we are using our doctor's approach. So we can just do the calculator and double check. So let's see, what is 10 of minus 315? So this is the test, guys, okay? So this is cos of 780. Here you went. What is that? Oh, I'm in stats mode. Goodness, I was wondering, what the hell? What the hell? It could not be wrong, man. This is 780. So please, yeah, I'm getting a half. So this one, the diagnosis is confirmed. So please check your answers, guys. If you don't check them, you're gonna die. You can't make a diagnosis that you have not ascertained, right? Or you will kill people as a doctor. Ninicera kakhulu man. Sanukuzenza lezi zinto man. Nizakubulala abantu. Anyway, let's do it. 5 marks, great. What is important to me is to show these reductions. It is important. And then what we can simply do is that reducing those together is important. And then reducing this to cos of 60 is important in the answer. So that's how you're getting the 5 marks, okay? So that's great. 3.3 says, determine the general solution. So this one is very good, guys. Please know how to do this effortlessly. It is very useful when you have graphs. When you're doing functions, you've got two functions intersecting at some weird point, general solutions will help you to find those coordinates. Or the reference angle for that matter. Anyway, let's go for it. Now we're given here 2 sine x cos x is equal to cos x. If you're in metric, you would say this. You would say this is a double angle for sine, but now in grade 11, you don't talk of double angles. But what I can see here, there's cos, there's cos. At times, this can hurt you, okay? But at times, you don't have a choice. All that matters is the technique. Okay, so what I can see, cos is common. So what I'm going to do here, I'll just divide by cos here. And then that goes. So I've got here 2 sine x is equal to 1. All right. And then this implies that sine x is a half, right? When you divide by 2. So therefore we can say, maybe let's not conclude just yet. So therefore this means x is equal to arc sine of a half plus k times 360 degrees or x is going to be 180. For sine, you consider two solutions. 180 minus arc sine of our half plus k times 360 degrees, where k is an element of integers. Okay, that is the story. Now we can make our conclusions. Maybe not yet. This implies that our x is equal to, maybe we can. Why do we want to prolong it? So Arcsine of a half is 30 degrees, right? Okay, you can use your calculator if you're not convinced. Now 180 minus 30 is 150. So K is an element of integers. Okay, that's it. Now let's look. What is the story? What is the story? The story is now we're getting 6 marks. I do believe getting this business here is important, and that stuff and that stuff is important, and that stuff and that stuff is important. So that's how we get our 5 marks. Okay, all right, okay. So now the 6th mark perhaps is the gymnastic of clearing things up here. So that's how we get it. Okay, so there are other means, man, but they'll pretty much make you go around in circles, if you ask me. Okay, so rather than to go around in circles, you are sorted. There are plenty of ways you can look at that, but let's not waste time. Let us not waste time. So question 4. Okay, so actually I was trying to write 16 marks because that question gives us a total of 16 marks with a big smile on our faces. Okay, let's move, guys. In the diagram below, graphs of f of x. So we're given a hypothetical equation. So whenever you are given a hypothetical equation, what are you supposed to do? We have to look in the diagram. But of note, we've got a, which is the coefficient of that function. And then we've got b, which is the coefficient of the angle. So it means things have been done to this one. So we need to check. This gives us the amplitude. In which case this can shed us the light about our maximum and minimum. Okay, that is what is important. And then this one can tell us stories about the period. Okay, so please guys, make sure these things are clear. Okay, now let's inspect what should look like the cosine graph here. The cosine graph normally starts at 0, so that is the story. It could be this one, it could be the other one, but technically they've labeled it for us, so we know we are in the right, because remember, a shifted sine graph can look like a cosine graph, and a shifted cosine graph can look like a sine graph. So you always have to make sure you watch the labels. Okay, so now we can see that that is the cosine graph, no problems. So cos of 0 is 0. Cos of 0 is 1, so that's fine. So if it goes to a maximum of 1, it means our amplitude is 1. Okay, so that means our maximum is going to go to 1. Our minimum is going to be minus 1. So remember these things, guys. They are very important. And as you can see, that cosine graph goes to a minimum of minus 1. Okay, great. Now, what do? We look again and say, fine, cos usually is 0 at 90. Now it's happening at 45 degrees. So what happened here? Stuff happened, right? And then we know also that cos of 180 is basically wait a minute, what am I saying now? We also know that, okay, let's look at this cosine graph a bit more. So if we follow this wave of the cosine graph, that usually Why is my hand getting stuck now? So basically that wave, that's a full wave of a cosine graph or cosine function. And it means it's completing its period at 180 degrees. Now this is the new period basically, because the old period was supposed to be 360. So what does that mean? We can look at it two ways and say the period of our function in essence is going to be the old period, which is 360 degrees, divided by the new period, which is 180 degrees. That gives us a ratio of 2. Or you can look at it as what would happen, the critical values. We know that cos of 90 is at 0. Now it's a different story. It's at 45. So we can say old critical value divided by the new critical value. That also gives us a 2. So that means our B value is a 2. Okay, so that is what you want to do always when you are given a challenge. Look at what should have been and compare it to what is the case, because we already know these graphs from grade 10. Okay, so you need to know that. Let me just remind you. So the critical values for these graphs is basically 90, 180, 270, and 360. Okay, so the same thing here. It's minus 90, minus 180, minus 270, 360. Okay, so here we will have just a 1 and a minus 1. Okay, please remember these shapes. We know the cosine graph does stuff like this. Okay, so don't worry about the fact that it's looking a bit ugly. Maybe I was supposed to make it a bit better. Let's just make it a bit better so that we have a nicer target, because this one is going to cause us a few problems if we don't make it right. Okay, so we're going to put 1 there and then minus 1 there. Okay, so basically the cosine graph does stuff like this. Okay, and then it continues to do stuff like that. Of course, you know what's going on. Of course, it's not on scale. Okay, so that's what the cosine graph would look like. Okay, that's it. But now, do you see what is happening with this cosine graph? You will see that it's ending at 180 instead of 360, because this is the most important. And then you see cos of 90 was supposed to be 0. Now it's at 0 at 45. So this is what gives you the understanding of how to work those things out. Not a problem. So we've got work to do. Now let's go on. We have found the values of a and b, essentially. Then let's look at the next function. Now the next function is g of x is equal to the sine of x plus p. Now that is a problem, because it says once we're adding a p, we are doing a horizontal shift. So this is the standard sine graph because the amplitude is 1. The coefficient of the angle is 1. So that means its period is still 360. Nothing changes. But we've just horizontally shifted it. We don't know whether to the left or to the right. But then we have to look into what is given. So there is our function of g. Now when we look at our function of g, we will see that, okay, normally sine of 0 is 0. But now what is happening? This is happening. This is happening 45 degrees earlier. Okay? Or 45 degrees later. It doesn't matter. Okay? Now, we can see that at the same time, the graph of sine at 90, it should be 1. Now, that is happening 45 degrees earlier because now sine of 1 is up there. Okay? So, what is happening? This simply means we shifted our sine graph to the left by 45 degrees. All right? Great. So that means our P is basically 45 degrees. Remember, when you add 45, you're shifting it to the left. Great. So we understand what is going on because that is the story, that sine graph is like this. The sine graph is like this. All right. So that's what a sine graph looks like. So you can see that at 90, it goes to its maximum. At 0, it is right at 0. So these are the things you want to make sure you remember and you compare. Always have these functions in your mind, or at least draw them out if you can. Then compare them with what you are given. That is the best way you can master the trig graphs, because I don't find any better way. Then of course, know your algebra and your trigonometry. If you know those, you will be in a good position. So this is basically your notes. NB, critical values. You have to know them. Because if you know those critical values, there is no function that is going to give you problems. All right? It's never going to happen. Now that we understand what is going on, so basically what we have, we know that our f of x is given by cos of 2x. Okay? And then our f function, our g function, is given by sine of x plus 45 degrees. Okay, that is what you can do. So you can use comparisons, or which is what I said, the doctor's approach, inspect, and then you reason through that. Then you make up your mind. So that's what we've got. Now let's start answering some questions, because those ones become a lot easier. So 4.1 says write down. So do you see, they don't care how you did it. Write down the values of a, b, and p. So we could see that our a is 1 because it's not really that bad. We worked out b is a 2, and I showed you how you would actually do it if you were to show the calculation. And then our p, we could see that this is 45 degrees. But there's a way you can look at it. You can actually calculate it by just looking on the graph and seeing what's going on. For example, if you take, say, sine of 0, sine of 45, for example. you would see that sine of 45 is a 1. And then you work it out. Let's take it, for example, and say sine of 45 degrees is 1. Okay? How would we deal with that? No. So this is basically going to say, this is going to say when x is 45, so we will have sine of 45 degrees plus p equals 1. Therefore, you know that when sine is 1, that is 90. So we can say now 45 degrees plus p is equal to arc sine of 45 of 1. Sorry, this is 90 degrees, and therefore our p is going to be 90 degrees minus 45, which is 45 degrees. So it comes out positive. So there's plenty of ways you can think about how to work out p. Like I said, to determine it is much sweeter because it saves you a lot of problems. So you get your 3 marks, nice and easy. They didn't care to ask you how did you do it. Now it says for which values of x in the given interval does the graph of f increase? I don't know why it loves hearts, this thing. As the graph of g also increases. Okay, so where do we see these ones increasing? Now, if you focus on this region here, look at this turning point, for example. Okay, because at the turning points, the graphs are stationary. So that one is stationary while the other one has a negative gradient before it. And we look at this region right here too. So if we look at this region right here, what do we see? We will see that these graphs, if we draw tangent lines, maybe let's do with a different color. So if you draw a tangent line here, what slope does it give us? A positive gradient. If you draw another tangent line, for example, on this one as well, what slope does it give? A positive gradient. And then, of course, a tangent line here is horizontal, so we're not going to use that. Even a tangent line there is horizontal, we're not going to use that. But we can see that these ones are both increasing in this interval. Okay, it's not included because one is stationary while the other one is doing what it's doing. So this is the interval of our solutions. Right. So we can simply say that our x must be less than 0, but greater than minus 90. That's it. So normally this one gives us 2 marks. Okay, so 4.4, 4.3. It says now, write down, again, a question that says write down, you just do it, the period of f of 2x. Now that's a bit silly, okay? F of 2x, remember f was already f of 2x. Now we are actually making it worse. So basically we are saying here we have f of 2x is going to be, maybe let's not do that. Oh yeah, maybe let's say f of 2x implies that we've got f of x is equal to cos 2 into 2x, okay? Because now we're putting the 2 also. So this is going to be cos of 4x. And then you know that we always are going to say, therefore we know that the period is going to be equal to the original period of a cosine graph divided by the coefficient of our angle, which is 4. So that will give us 90 degrees. All right. So, but they said write down. So this is essentially your determination. This is basically your stories there. This is what you would do on your rough work. You're not going to write on your script. If you write it on your script, not going to get extra marks. So you can just write here the period T is 90 degrees. That's it. But this is your reasoning. This is how you work it out. All right. Not a problem. So, easy stuff. Now let's do 4.4. 4.4 says, determine the minimum value of h of x equals 3 times f of x minus 1. Let's first sort out. This is 3 into f of x is cos 2x, okay? And then we are subtracting 1 from that, okay? This becomes now 3 cos 2x minus 1. All right. So remember, this would give us the amplitude. Now, when we want a minimum value is going to be minus 3. But we are vertically shifting this thing by 1 unit further down. So what do we say? So we can say, therefore, the minimum value is going to be equal to minus 3, which would be the minimum, and then we subtract minus 1 because we are shifting it down. That becomes a minus 4. Okay, nice and easy. So what matters here is essentially, I don't know guys, yeah, there's plenty of areas to look at. This one is a mark, definitely, maybe, whatever. 2 marks there, 4.5. 4.5 says, describe how the graph of G must be transformed to form the graph of K, where K equals. Okay, now we see here, we ended up with a cosine graph from a sine graph, and the 45 is missing. Okay, so what did we do here? So we lost 45. So how is sine related to cos? Obviously, these are co-ratios, are they not? These are co-ratios. So, but in any case, let's think about it for a second. What did we do here? To get a cos from a sine graph, we can shift the graph of sine to mimic the graph of cos even. We don't need to do other things. So we've lost that 45. Then it means if we shift it 45 degrees to the left, what happens? That would be at 1. So that simply says for us, we are doing this to this graph of sine. So when we shift it, it's going to come. Let me show you, just in case you're not seeing it. So let's just do the things. So now, you see, if we're shifting this graph 45 degrees to the left, look what happens. It looks like the cosine graph because now 0 becomes the maximum. You get me? So that is the story. So to do this is very easy. We can see that if we took, for example, our sine graph and shifted it 45 degrees to the left, it essentially becomes what we want. Ne? Yeah, it becomes what we want. And at the same time, yeah, we just shifted 45 degrees back. It looks like the cosine graph. Now I'm trying to think, guys, because it needs to make sense what we are doing. So we can say K of x equals minus cos x is the graph of g of x equal to sine of x plus 45 shifted 45 degrees to the left horizontally. I don't know why I sent Palegagbi. Say we are watching food. So this is going to be the graph of g of x equals that shifted 45 degrees to the left and reflected about the x-axis. Okay, because we flipped it for it to be negative. Think about it. If we're doing that, remember, if we're saying it's a horizontal, it's a vertical shift, so we can say now g of x was sine of x plus 45, and we're shifting it 45 degrees to the left again. And then if we're reflecting it, we're going to multiply it by negative, right? So that is our k of x. Then we say this is minus sine of x plus 90 degrees. Co-function there, remember, sine x plus 90 is in the second quadrant, so sine is positive, so the co-ratio is going to be positive, but that negative is dragging, so this is going to be cos x, which is exactly what we are saying. Okay, so you can do some checks on the side to confirm if your answer is correct, like I said, and then you make up your mind. Right, so that's how we're getting our 2 marks. I guess first is to say shifted 45 degrees and then the reflection about the x-axis, and that gives us our 11 marks of that question. Okay, let's move on to the next question. Question 5. Okay, so let's try to move a bit quicker. So I told here in the triangle ABC, C is theta and AB is equal to AC equal to y. So if that is the case, we already know that this is also theta, right? These are the base angles of an isosceles triangle, or what they simply call nowadays angles opposite equal sides in a triangle. Okay, great. So when you're dealing with these 3D structures or 2D, and of course in grade 11 you're dealing with 2D, so it's 2 dimensions, but in grade 12 you're going to get it a level higher, which is 3D, which is not really that different. It's a lot of 2Ds. Okay, now what are we doing? We always calculate all possible angles, so that angle here is going to be 180 degrees minus 2 theta, right? Because the sum of 3 angles are going to give us that. And then now I told you, show that BC is equal to 2 into 1 plus cos 2 theta. Obviously, once we see a square root sign, we know that of the triangle rules that we must have used is the cosine rule. Okay, so please identify what would work, because it makes life a lot easier. So we can start and say here in triangle ABC, we want to work things out. We know that angle B is going to be equal to angle C equals theta. Why? This is angles opposite equal sides. That's it. We can say here, then we know that angle A plus angle B plus angle C equals 180 degrees. This is sum of 3 angles of a triangle. Okay? From here, we know that this implies that angle A plus theta is equal to 180 degrees. We can then stop the business right in its tracks. So theta plus theta is 2 theta. We have to show that angle A is like that. We can say, maybe let's just say here also instead. We can say then, what do we know? BC squared is going to be equal to AB squared plus AC squared minus 2AB times AC cos of A. Why is this? This is the cosine rule. Okay? Please identify your stuff. Don't be a hooligan. It doesn't help to be one. And let's substitute. What is that? This is y minus 2 into y cos A is 180 degrees minus 2 theta. Okay, so we're doing fine. Let's do it. So this is going to be y squared plus y squared. This is 2y squared minus 2 into y squared. Now into this one, 180 minus is in the second quadrant, so cos is negative. So this is minus cos 2 theta. We're using our reduction formula. This is 2y squared. Now minus times minus is a plus 2y squared cos 2 theta. Okay, so what do? We factor out this thing. We can see that 2y squared is common to both. Like that. And then we can say therefore BC is going to be, when we take the square root of what we've got over there. Sometimes this thing refuses to do the things. Hi, when can to 10 was slow. For no one laying 2y squared into 1 plus cos 2 theta. Anyway, it is on my case now, which the square root of y squared is just y. Okay, now 2 remains because we don't want that, plus cos 2 theta, and that's our answer. That's our answer. So easy stuff. So this one was a bit of work because of importance is this angle. Okay, that angle is important, and then substitution into the cosine rule is important, and this reduction here is important, and then how we factorized is important, how we took the square root is important. The answer was already given, so it's 1 2 3 4 5. So where's the 6th mark? That is important, of course. Without it, we would not progress. So we take the 6 marks of this question with a big smile. Now let's move on. Question 6. Now question 6 says, what is the stuary? So this is now, we're talking of, is it shapes or what? Yeah, stuff like that, but whatever, man. This is somewhat the same thing as the, what you call, the 2D stuff. This is what we are looking at essentially, but it's more of a 3D if you think about it. It's not really a 2D, it's a 3D structure. But let's just move on. So we are still in the same bracket basically. Now it says the perpendicular height, so that's stuary there, the perpendicular height AC, and it's already indicated, of the solid cone below is 2 meters. Okay, and the radius is r. So if it is not given, we may need to find it. AB is a slant height. Okay, great. Now we're told here BAC is 36 degrees. Not a problem, it's also indicated. Now you can see here we've been given some clues here that to calculate the surface area of a cone, we say pi r squared plus pi rs, okay, where s is the slant height. And then we can do the volume when we take 1/3 of the area of the base multiplied by the perpendicular height. And we can also do the volume that says 1/3 of pi r squared times height. Now that's the volume of what? When? Oh yeah, that's the same thing, man. It's just the formula for the same thing. I was wondering what is going on now. So this is the same thing as what we are given. Okay, not a problem. So what do we do? Now it says calculate the total surface area of the cone. Okay, so that is where our question is. So what do? We need r. But now we can use this triangle to sort out r. Can you see this triangle here? This is a right-angled triangle. So we've got the adjacent, we want the opposite, we've got the angle. So we can say now in triangle ABC, always state where you are so that you don't get us confused. We know that sine, not sine, but we wanted the opposite side, so this is 10. Tan 36 degrees. It's going to be the opposite, which is BC, over the adjacent, which is AC. This implies that tan 36 degrees. Please be patient sometimes, don't rush. You will be in trouble. It's going to be r over 2. That is over 1. We just cross multiply. We can simply say therefore our r, because that's what we want, is going to be 2 times tan of 36 degrees. Which is, let us do the things. So 2 into tan 36 is 1,453. Of course, we don't round off to 2 decimal places too soon, okay? So meters. We needed that r. Is there anything else? We need the slant height. The slant height is important as well. So we can say also in that same triangle, we can see that we've got the adjacent, we want the hypotenuse. So this is the same as cos of 36 degrees. It's going to be the adjacent AC over the hypotenuse, which is AB, which implies that cos 36 degrees is equal to, this is now AC is given to us as 2 over, now the hypotenuse is AB, which is what we want. We can say this implies that AB, of course this is over 1, and then cross multiply and sort things out. It will be such that AB is going to be equal to 2 over, maybe we can even make a conclusion instead. AB is going to be equal to 2 over cos 36 degrees. So 2 divided by cos 36 is basically 2,472. Okay, you don't want to round off too soon, so you take a bit of time. Now that we've got this thing, we can say then what? We can see that the surface area of cone is going to be equal to pi r squared plus pi rs. This is pi into our r squared is 1,453 squared, plus this is pi into r it's 1,453 times the slant height, which is 2,472. So we just simply deal with that in the calculator. So we're going to say shift and we press that exponent number. It gives us the pi into 1,453 squared plus shift pi into 1,453 into 2,472. Alright, so our answer there is 17,92. Now remember, an area is in meters squared. That is the story. So we are sorted, guys. Nice and easy. Okay, so it's almost time up, guys. I took forever, né? It's fine. So can you see, this was also a bit of a situation because we needed to find r. We needed to find the slant height and then substituting into a correct formula, and the answer is 1, 2, 3, 4. And then we can say this substitution to the left and to the right. I don't know really, guys, but yeah, you've got 6 marks. I still have 5 here. 1, 2, 3, 4, 5. So no, maybe we can simply say these substitutions right there are the most important. So it's 1, 2, 3, 4, 5, 6. Yes, it's balanced. So we take that 6 marks with a smile. Be like, okay, we are doing great. So now let's get to Euclidean geometry. So question 7. Okay. Now you would be told, time up, boys and girls. So, but let's just enjoy this and not worry about time anymore. 7.1 says, complete the statement. Okay. A line drawn from the center of a circle is dashed to the tangent. It's perpendicular. Is perpendicular. So to answer 7.1, we'll just say perpendicular. It is basically, that is the story. So 7.2, Says now, in the diagram below, so the doctor's approach here, AOD is a diameter, okay, of the circle, and EDF, so let's first isolate, where is that AOD? There is our AOD, okay, with that center right there, okay, not a problem. So what do we know about what you call a diameter? It subtends a 90 degrees at circumference. So that's what we've got. So it's 90 degrees there. So always get the statement, do your inspection, make an interpretation quickly. And then the next business says, and EDF is a tangent. So this is a tangent, EDF. Ndifuna ulale phezu kwale line wena mandisunqeni. Yeah, pap. Anyway, it's fine. Let's leave it. Pap injal. Now, what do we get? If this is a tangent and that is a diameter, we know without a shadow of a doubt that that angle is 90 degrees. All right. Okay. All right. So let's just do it here. I don't know now. Things are just trying to irritate me. So that is also 90 degrees. Not a problem. 2. Okay, let's read. Now to the circle at D. Okay, that's fine. So this is the point of tangency there. Then ADB is 62 degrees. So it's indicated. And BC is equal to CD, also indicated. Okay. Not a problem. So what can we do with this? We know that we've got our friend called the tan chord theorem. So this guy is going to be equal to that guy. Okay? That's tan chord theorem. As well, we know without a shadow of a doubt that this guy as a whole is equal to that guy. That's a tan chord theorem. Okay, easy. Okay, the other thing that this is a cyclic chord, so opposite angles are supplementary. Not a big deal. Let us do our business. Now 7.2 says we've got 7.2.1. Calculate with reasons the numerical value of BCD. BCD, so this angle right here. Okay, so how do we deal with that angle? The best for us is to start in this triangle. You see, if we start in this triangle here, you will see that we've got more than enough. We need to find A. Then, after that, we look in the cyclic quad, ABC. Those two are supplementary. So we will do stuff like that eventually. We know that those two will add up to 180 degrees. All right, not a problem. So that's fine. So let's start. We will say now in triangle ABD. What do we see there? We know that angle A plus angle B. Okay, maybe let's start by accounting for angle B. We can see that angle B is equal to 90 degrees. This is the angle in the semicircle. Okay, now we can say now also we know that angle A plus angle B plus angle D. You can say D3 if you like, but I've already stated the triangle I'm talking about, but maybe let's just do it. D3 is equal to 180 degrees. Now again, what is the story there? This is the sum of three angles of a triangle. We already stated what triangle we're talking about. This implies that angle A, that's where to kwenzeka enibhalekayo up, plus 90 degrees, plus that D3, which is 62 degrees, is equal to 180 degrees. Therefore, our angle A is 180 degrees minus 90 degrees minus 63 degrees. Okay, so let's do it. So 180 degrees minus 90 minus 63 is 27. Okay, so that's another piece of information that we need. Okay, now we can say then we know that angle A plus angle C equals to 180 degrees. Okay, but let's just write it the way they wrote it. You know, sometimes it's nice to keep things as they are. Is equal to 180 degrees. Again, what is the story here? These are the opposite angles of cyclic quad. Sometimes I like to name it A, B, C, D. As much as it was not stated, we can see that all those points A, B, C, and D are concyclic. So if they make a quadrilateral, it is a cyclic quad. Okay, all right, okay. So this implies that 27 degrees equals 180. We can say therefore this angle BCD is going to be 180 degrees minus 27 degrees. Okay, so this is 153 degrees. Is that true? The answer is yes. Because even though the diagram may not be drawn to scale, but that is an obtuse angle. And that is also an obtuse angle. So we are sorted. So you see, there was a bit of work to be done. So that statement is powerful. This one is great, but we normally don't get a mark for that reason because it's a grade what? You start knowing this in grade 9 or so. So we don't really take it seriously. Okay, maybe we should. Sorry. And then this one is a grade 11 reason. It's powerful, okay? And then the answer. Okay, great. So let's move on. 7.2.2. We are looking for CDF. CDF. So this is the guy we're looking for. So obviously we need to find a way of calculating this guy. So what is the value of that guy? Now if you look at this triangle right here, what color must it be? Maybe this color is fine. So if we look at this triangle right here, so let's look at that lovely triangle. What do we see in that triangle? It's an isosceles triangle. Yes, it's not drawn to scale, but the suggestion is saying it's an isosceles triangle. We know C. We just calculated it above, so we can actually calculate B2 because that's what we want. We want B2 as a means to an end. So we can say in triangle BCD. What do we know? We know that definitely angle B2 is equal to angle D2, right? what is the story? These are the angles opposite equal sides. It was given that BC is equal to CD. Okay, you always want to be comprehensive about your reasons because you are trying to convince someone that you know. And then what is the next step? We can say also in that same triangle, we know that angle B2 plus angle D2 plus angle C, I'm just going to keep it as C, these are equal to 180 degrees. Again, what is that? Sum of three angles of a triangle. We've stated what triangle we're talking about, so we can just simply jump in. B2 plus D2, because these two are equal, we can just say twice B2 because we want our B2 to come to our rescue. So that one was 153 degrees is equal to 180 degrees, which implies that 2 angle B2 is equal to 180 degrees minus, maybe let's not prolong this business, it's getting boring, don't have space and time. Therefore, angle B2 is going to be 180 minus 153 degrees divided by 2. Okay, so we can say now 180 minus 153 divided by 2 is giving us a 13.5 degrees. Okay, now we can say, okay, we'll say, but we know that angle CDF is equal to angle B2. This is the tan chord theorem. Okay, then we have found the value of CDF. Nice and easy. So those are the nice questions ever. They are the nicest questions ever. So if you think about that statement and its reason, it's mark worthy. And the other mark worthy business is this statement and its reason, leading us to this answer if you want, and then we can mark that statement and answer. This is simply the repeat of the same thing. Okay, so an answer is not necessarily going to be awarded marks. That's how we take our 9 marks with a smile on our face. So let's do question 8. So question 8 says, use the sketch on the diagram sheet to prove the theorem which states that. Okay, let's go look for that sketch. There it is. So we've got fancy things, doing fancy stuff. Okay, all right, okay, I think the sketch is big enough before it starts looking funny. We have to keep it looking like a circle. Okay, that's fine. Now we're doing 8.1. So it says we must prove that BAT, this angle, is equal to angle C. So that's what we are trying to prove. All right, not a problem. So what do we do here? We first do a construction through the center. So we construct that diameter and we connect that back to where we are trying to get to essentially dividing that into 1 and 2, 1 and 2. Okay, so a construction is a dotted line. Simply don't do, because we'll be using the same color. If you're using different colors, it would make sense. But what I would like to do is to call this one, this is now CB, maybe let's say BC, ABC, and then we can put a D there. I will give that D. It makes life easy. But it doesn't look like a D now. Oh, D1 always never looks like a D, eh? Whatever. So we can say here we are given. What are we given? We are given circle, center. We are given circle through A, B, and C, and tangent PAT. Okay, that's what we are given. Circle center O through whatever. And then now, what are we required to prove? We are required to prove that BAT is equal to angle C. Okay, the original stuff. In this case, we have called it C2, so we're going to place a C2 there. We are modifying it because it won't make sense. Oh, we can't say C2, by the way, because we haven't done anything. And then we're going to say construction. What do? We can say draw diameter AOD. Okay, can say now join CD. Great, that's it. All right, so you just number things as we are. Maybe we can say such that C is divided into C1 and C2, and A is divided into A1 and A2. Because you have introduced things, please tell us about those things. I don't know, my writing just decided to die at that point. Then we can start with the proof. Now, what do we know? We know that C1 plus C2 are equal to 90 degrees. That's an angle in the semicircle, because we drew a diameter, so that is the angle subtended by the diameter. So that is the story. So that is it. So now we also know that this angle here is also 90 degrees. So we can say also we know that angle A1 plus angle A2 are also equal to 90 degrees. That's the radius, or yeah, I can just say radius perpendicular to tangent, because we know that there's a tangent there. Ah, how very nice, how very nice, how very nice, how very nice. Now we've got a story to tell. We are like, but hold on. We know that this dude is equal to that dude. How do we know this? These are angles in the same segment subtended by arc DB. All right, we see that. So we can say C1 is equal to CA is equal to A1. These are angles in the same segment subtended by arc DB or BD. Whatever. So you want to be very clear about where to. Don't want to take too many shortcuts. So what does this imply? Maybe we can say that implied already that C1 plus C2 is equal to A1 plus A2, right? But what angle are we looking for? A1 first, so maybe let's start there. Let's start there because we needed to make that conclusion. So let's move you, sir. You came in too early, okay? So we can say that implied that angle A1 plus angle A2 is equal to angle C1 plus angle C2. Okay, we can say each equals 90 degrees. I mean, you don't need that reason. It's a weak reason because we've already stated it nice and clearly here and there. Okay, so what is the story then? Now when we factor this guy in, what do we say? This implies what? Now in our equation, we're going to say, without a shadow of a doubt, that A1 plus A2 is equal to, instead of C1, we're going to write A1 plus C2. We're already substituting so that these dudes can do this thing that we want, so that we can make our conclusion and say, therefore, A2 is equal to C2. We can say, therefore, make that conclusion that they asked you. Therefore, BAT, because BAT was A2, right, is equal to C. That's it. Because that C2 was a C in the original. That's the answer. Okay, easy. Very nice and straightforward. I won't even waste my time on how many marks you should be getting there. 8.2. So let's see. Usually this one becomes a bit more challenging. That one becomes a little bit more challenging, so you need to keep your eyes and ears opened. Your doctor's approach needs to be on point. In the diagram, PQ is a tangent. Okay? So let's highlight the tangent. Okay? To the circle QST. QST. So let's just do QST. We'll just highlight that triangle because that's what matters in our 10-chord theorem. Okay, that's our circle QST, such that QT is a chord of the circle and TS produced, now TS produced is going in that direction. Okay, TS produced, so once you hear that word produced, you are being told this is a straight line. Basically, PST is a straight line to meet the tangent at P, okay? R is a point on QT. There is R such that PQRS is a cyclic quad. Oops. Maybe it would be best if we just shade the cyclic quad because now we've already made some nice highlights, so it's going to be a bit nasty. It will be better if we just shade our cyclic quad so that we can work nicely. Okay, there's our cyclic quad. We can see it nicely. Is a cyclic quadrilateral in another circle. Okay, PR and QS warawara are joined. Okay, we can see that. Now we have to hustle, but now before we hustle, we always have to look in our diagram. Now we have to inspect it. What do we know? If this is a tangent and that is a chord, it means this angle is equal to that angle. Ne? That's a 10 chord theorem, right? Because the angle between the tangent and the chord QS will be the angle subtended by chord QS at circumference, which is angle T. That's number one. There's a lot of things here to say. So guys, be careful. Don't overly do it. The other thing that we can say is that this angle is equal to that angle. Right. What is the story there? Those are the angles in the same segment subtended by chord QR in that smaller circle. Likewise, this one is equal to that one. Ne? Why is that? Those are angles in the same segment subtended by chord RS or arc RS. Yo, we have another business here. We know that this Q1 is also equal to R2. Right. Why is that? These are angles in the same segment subtended by chord PS. Ya maniac. Ke mollo jwale. A ke tsebe ke tla etsa jwang jwale ntwena. Now we can see that also this angle is also equal to that angle. Again, angles in the same segment. Now you can see our diagram is a bit of a mess, but that is what it is. What can we do? There is a lot of things to think about. There's exterior angles of a cyclic quad. For example, look at P1 plus P2. It is equal to R3. Okay? So sometimes, you see that angle is equal to this angle. That's an exterior angle of a cyclic quad. So there's a lot of things to consider. So let's just leave it now before we start messing up. Now let's start working. 8.2.1 says, give a reason for each statement. Write only the reason. Okay? We just want the reason. So 8.2.1a, we're told Q1 is equal to T. Why is it so? 10 chord theorem. Okay. B, Q2 is equal to P2. Yes, we could see that. What is that? These are the angles in the same segment. Okay, leave it like that. So now we've got 8.2.2. It says now prove that PR is an isosceles triangle. Sorry, PQR. Okay, so if we want PQR to be an isosceles triangle, so this is basically the triangle we're talking about now. So that is the triangle of our interest. Okay, the one that is stippled. Now we can see here we have a bit of work. Okay, now how do we prove that? Lord of Lords. Well, let's see. Can we prove that R1 is equal to P1? Doesn't look likely. But. Yes. This is dangerous. This is dangerous. Look at this triangle. I'm going to outline this one like this now. Look at that triangle. What do we see? That triangle PRT. Triangle PRT has an exterior angle which is R1. Ne. Yeah. So let's start there and say, look, R1. Let's work out R1. We can use that because what I know is that Q1 is equal to T. So this plus that will give us that. At the same time, this is equal to that and this is equal to that. It's common. So these two, Q1 plus Q2 is the same as R1. But we can use this triangle. Say in triangle PRT. Okay, so triangle PRT, we can see without a shadow of a doubt that angle R1 is equal to angle P2 plus angle T. What is it? This is an exterior angle of a triangle. We've already stated what that triangle is. Okay. All right. Okay. Ne. Yeah. But now, what do we know? We know from above that P, okay, maybe let's see. Whew. I'm trying to see now, what am I gonna do? What connections do I want to make? I want to make these connections that we know that this therefore tells us that R1, just want to do a fancy thing now, is equal to angle P2 plus, maybe let's do something fancy. Let's do a fancy gymnastic here. It's going to be great. Instead of P2, we've already proven above, we're given pieces of information. We can use those. Instead of P2, we write Q2 plus, instead of T, we can write angle Q1. Right. Why are we doing that? It's because we know that P2 is equal to Q2. And we can say angle Q1 is equal to angle T. Okay, it's proved above. Maybe we can say it's proved that. Yeah, I don't know, guys. Sometimes the reason can be a bit nasty. Depends, but I think it's best if we start it by saying, okay, let's try to be right. Let's not be hooligans. Why are we in a hurry? We've already lost time, boys and girls. But we're right at the end. We can say it is proved that angle P2 is equal to angle Q2 and angle T is equal to angle Q1. That is in 8 point some change. You can answer that question. So that is important. And now what do we see? We can therefore see clearly that if we can prove that that is the case, I mean, this is so nice, guys. Look at that. R1 is equal to, so we can say therefore angle R1 is equal to the sum of, let's just call it PQR. Okay, so that it makes a bit of sense, otherwise it's going to be ridiculous. If that is the case, we can say therefore PQ triangle PQR is an isosceles. Isoscaline, isoscaline, it's an isosceles triangle. What is the reason? We have a converse. Okay, we can just say base angles proved equal or angles opposite equal signs. We can just say, man, converse of angles opposite equal signs, sides. Yes, because we normally get told that those sides are equal and therefore the angles are equal. Now we started with the angles, then it should be the converse. So that's it, guys. That's it. Nothing big. So basically this is a very, 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 very important stuff. Okay, that's a very important stuff. Maybe here we can just say here then, and then we sort it out, and then we can see here that wow, those things are very interesting. And then what do we do here? I think this statement is key in a way, and then this statement is key also. And I think this gymnastic of substituting one into the other is also important. So let's finish this painful business. 8.2.3. I have a MotoGP race to watch next, so let's quickly finish. It says now prove that PR is a tangent to the circle RST. Okay, so we are looking at this circle RST. Okay, circle RST, what is so special about it? We can see that definitely R2 is equal to Q, is equal to T. But we needed to make that connection. So we'll start there, connect it here, then connect it there. Then the 10-chord theorem converse is swatted. So we can start, okay, all right, okay. We know without a shadow of a doubt that Q2, because we want R2, sorry, is equal to Q1. What is that? These are the angles in the same segment, subtended by chord QPS, sorry. Okay, that's it. Number one. But we've got a story to tell. We know that angle Q1 is equal to angle T, right? This is proved above. Right, we say therefore R2 is going to be equal to angle T. That's what we wanted to connect. If that is the case, we can say therefore PR is a tangent to circle through. Okay, maybe let's write it as they wrote it, to circle RST. What is our reason? This is the converse of the 10-chord theorem. All right, guys, that's it. That is the story. So here we were getting just 3 marks. That is key. Right. And then this substitution is important, and then this final statement with the reason, essentially. And that's how we scoop up those 15 marks, and we're taking our 100 total. Okay, so that's the end, guys. I hope you enjoyed the video. Otherwise, I will see you some other time.